Hi students, welcome to today's class. Today I am going to explain ratio of consecutive terms, consecutive coefficients. So in the binomial expansion, so we have once again I will write down the expansion x plus y whole power n. So this is nc0 x power n, nc1 x power n minus 1 into y. Next to nc2 into x power n minus 2 into y square plus so on. Last one, next ncr into x power n minus r y power r. So on. Last term is ncn y to the power of n. So this is called binomial expansion where n is a positive integer or natural number. Okay now, right. Now coming to the ratio of consecutive terms and consecutive coefficients. So let us see the binomial coefficient. So here what is a nc1 and nc2? These two are called consecutive. That means side by side. And this nc0 and nc1, these two are called consecutive. For example, in between ncr minus 1, ncr and ncr plus 1. So if you observe here, ncr minus 1, ncr, both are consecutive. ncr plus 1, both are consecutive. Now we are going to see the ratio. Okay now. So very nice formulas are there depending upon that. The very first formula is ncr by ncr minus 1. So this is given by the formula n minus r plus 1 by r. Sir, how to remember? So this we have the proof. We can prove this, no problem. So here n factorial by n minus r factorial into r factorial. This is n factorial by n minus r factor, n minus of r minus 1 factorial into r minus 1 factorial. So if you apply the formulas and if you simplify, you will get this answer. Okay now. Then how to remember? How to remember is, see here, n. So whatever may be the, so first thing is n, both should be same. Second thing what you have to observe is, if it is r is there, r minus 1. Next one less. If it is a 4, it is a 3. If it is a 7, it is a 6. Like that should be there. One number less. Then the answer will be n minus you do. That means n minus r minus 1 by. The whatever may be in the numerator, this suffix is no same will come. So same answer, n minus r plus 1 by r. Understand? Now second formula is, so if it is a ncr plus 1 by ncr plus 1 by ncr. Now what is the answer? So both are consecutive or not? So here r plus 1, r 1 less. So what you have to do, how to remember? So concentrate on denominator. So n minus r by whatever may be the value here, same thing will come, r plus 1. Understand? That's all. Next I will tell the, for example, n plus 1 c r plus 1 by n plus 1 c r is there. So here n plus 1, r plus 1, r. Here n plus 1 c r plus 1 by n plus 1 c r. Here n plus 1 is there, r plus 1 r, 1 less. Therefore, what is the answer? N plus 1 minus r. So this is n plus 1 minus r. Whatever may be the numbers will come down, r plus 1. So that is the answer. Okay. So based on this concept, so we have a very, very important problem. So let us see that problem. Welcome back here. So let us see this problem. If CR is equal to NCR, that means if NCR there, that is shortly written as CR. That means we will simply avoid N. Then prove that C0 plus C1 into C1 plus C2 into C2 plus C3 multiplied by Cn minus 1 plus Cn is equal to C1 into C2 into C3 so on, Cn minus 1 times Cn. Again this times n plus 1 whole power n by n factorial. Okay now, let us do this problem. So this, since it is a prove that type of problem, let us do left hand side is equal to right hand side. So what is a left hand side here? This is a C0 plus C1, C1 plus C2 multiplied by C2 plus C3 so on Cn minus 1 plus Cn. Okay now? See the right hand side part. So right hand side part here, C1 into C2 into C3. C1 is there, C naught is there. That's why in this factor C naught plus C1, let us take C1 common outside. So if you take C1 common outside, so I will just reverse it, 1 plus, so this is equal to C naught by C1. Understand? Here you take C2 common outside, so this is a 1 plus C1 by C2. If you take C3 common outside, 1 plus C2 by C3. So on, if you take Cn common outside, 1 plus Cn minus 1 by Cn. So Cn plus Cn minus 1. Okay now? Now I will rearrange the factors. So here this is equal to C1 into C2 into C3. C1 into C2 into C3, so on Cn into 1 plus C naught by C1 into 1 plus C1 by C2 into 1 plus C2 by C3 plus so on 1 plus Cn minus 1 by Cn. Understand? Now the formula which we explained will come here. So I will write down once again that formula, NCR by NCR minus 1 is equal to, if it is R, here R minus 1 less, so that is equal to N minus R plus 1 by R. If the same formula is reversed, that means here NCR minus 1 by NCR is there, R by this subtraction, N minus R plus 1. Okay? If it is R minus 1, here R, the thing is reverse. This formula also will become reverse, numerator by denominator. Let us see here. So here the problem is, so this is equal to C1 into C2 into C3, so on. This is a 1 plus, see here, C naught means what? NC0 by NC1. So what is a NC0 by NC1? So NC0 by NC1, see here, NC0 by NC1. So what will come here? Whatever may be the here R directly will come here, 1 by N minus 0, 1. 1 by N will come. Understand? N minus 0. So, see here NC0 by NC1 is equal to 1 by N. How? According to this formula, NCR minus 1 by NCR is equal to, so here R will come, so whatever may be the subtraction here. So the concepts is same here also. So NC0 by NC1, here whatever may be that will come here, 1 by N minus 0, that is a N into 1 plus, here whatever may be the here, 2 will come, so 2 by, this is a N minus 1, 2 by N minus 1. Understand this? N minus 0, N minus 1. So again this is a plus 3 by N minus 2 plus so on. So this is equal to, so on 1 plus N by, so this is a N minus of N minus 1, this is a 1 you will get. Okay now? Now you simplify that, you will get the answer. So almost you will get C1 into C2 into C3, so on Cn. So take the here LCM, N plus 1 by N. So here also LCM, if you take a N minus 1 plus 2, N plus 1. So this is a N plus 1 by N minus 1. So here also N plus 1 by N minus 2. So last one, N plus 1 by N. So this is equal to, so this is a C naught into C2 into C3, so on Cn. So this is a N plus 1, N plus 1, N plus 1. In the numerator, how many N plus 1s are there? There are N factors are there. So how can you say that? So here, see here, 1, 2, 3, so on N. There are N factors. That's why those N plus 1s are there. N number of N plus 1s are there. That's why we can write down N plus 1 whole power N. So denominator you see here. So here 1 will come. So 1 into 2 into 3 into so on, N minus 2 into N minus 1 into N. So that is the product of the first N consecutive natural numbers. This is simply denoted by N factorial. Got it or not? Same answer, we got it or not? Understand this? So this formula problem is done using simply this formula. Okay. okay, using this concept. Okay, now, right. I hope that you understand this problem. So let us go for next concept. Dear students, welcome back to this problem. So find the sum of sigma r runs from 1 to n r into NCR upon NCR minus 1. Okay, now, so let us see the solution. So the solution is a sigma r runs from 1 to n r into that formula we know, NCR by NCR minus 1 formula. So that is equal to n minus r plus 1 by r, n minus r plus 1 by r, n minus this, same r will come. Is there any more cancellations? Yes, we can cancel RR clearly. So this is equal to sigma r runs from 1 to n. Write down n plus 1 minus r. Write down n plus 1 minus r. We can apply sigma for both the terms. So this is equal to sigma r runs from 1 to n, n plus 1 minus sigma r runs from 1 to n into r. See here, there is no r term here, therefore n plus 1, treat it as a constant, we can take it as a outside. So this is equal to n plus 1 into sigma r runs from 1 to n, just simply 1 is there. So this is a sigma r runs from 1 to n r. So this is equal to n plus 1 into sigma r runs from 1 to 1 means what here? 1 plus 1 plus 1 plus 1. How many ones are there? N ones are there. That's why we can write it as a n minus sigma r runs from 1 to n. Sigma r runs from 1 to n. R means what? First you have to substitute r is equal to 1. 1 plus 2 plus 3 plus so on n. That is sum of the first n natural numbers. That is a n into n plus 1 by 2. Okay. So let us, any more common we can take? Yes, we can take a n into n plus 1. n into n plus 1. n into n plus 1. This is equal to 1 minus 1 by 2. n into n minus 1 we can. So this is equal to, that is a 1. So n into n plus 1 by 2. So this is your final answer. Okay, now. So this problem can be done by using the formula NCR by NCR minus 1. So this is the solution for this problem. Okay. So I hope that you understand the solution. So let us move to one more concept. Dear students, see here one more important concept is applications of binomial expansion. Applications of binomial expansions. Let us see this one binomial 1 plus 1 by n whole to the power of n. 1 plus 1 by n whole to the power of n, where n is greater than or equal to 1 and n belongs to n natural number. Okay, now, right. So if any binomial expansion is like this, its value lies between 2 and 3, but not 3. From 2 to 3. 3 does not equal to 3. Understand? For example, if there is any answer is there, for example, if you want to find out the value of 1 plus 1 by 3 whole to the power of 3. See here 3 is there, 3 is there. Its value lies between 2 to 3. Understand? Otherwise, let us take one more example. 1 plus 1 by 2 whole square. 1 plus 1 by 2 whole square. See here, 1 plus 1 by 2 is equal to 3 by 2. 3 by 2 whole square. Okay, so 3 by 2 is equal to how much? 1.5 whole square. This is a 2.25. 2.25. Is 2.25 lies between 2 and 3? Yes. Understand this? If you take n is equal to 1, 1 plus 1 by 1 whole power 1. 1 plus 1 is equal to 2. That's why 2 less than or equal to 2 is there. So that means whatever may be the value you take here, n. For example, 1 plus 1 by 2023 whole to the power of 2023. 1 plus 1 by 2023 whole to the power of 2023. This value lies between 3 and 2 and 3. This value lies between 2 and 3. Okay, now. So this is a very, very important application of the binomial expansion. So based on this, we have one nice problem. So let us solve that problem. Welcome to this problem. So here, find the positive integer just greater than 1 plus 0.0001 whole to the power of 1000, that means 10,000. Then how to do this problem? So let us see this problem. This is a 1 plus 0.0001. So this is a decimal fraction. You can convert this into as an ordinary fraction. 1, so 1, 2, 3, 4, 4 zeros, 1, 2, 3, 4, whole to the power of 10,000. 1 plus 1 by 10,000 whole to the power of 10,000. So just now we have seen the result, that is a 2 less than or equal to 1 plus 1 by n whole power n less than 3, where n greater than is equal to 1, n belongs to natural number. So here what is a n? 10,000, that is greater than 1. So is it just like a 1 plus 1 by n whole to the power of n form? Therefore, this value lies between, that is 2 and 3 by 10,000 whole to the power of 10,000 less than 3. Understand this? The whatever may be this value, it lies between 2 and 3. Now the question is, find the positive integer just greater than this. That means this value is up to 3 only. That means 2.9999. What is the next positive integer? What is the positive integer? Means 3. Therefore, this answer is equal to how much? 3. What is the value? The positive integer just greater than this value is 3. Understand this? Just greater than this is 3. That means this value is lies less than 3. Next positive integer means 3. Therefore, 3 is your answer. That's all. That means what? If you want to solve this problem, you must know this concept. Understand this? That's why you write all these concepts in a notebook, separate notebook for only concepts. Separate notebook for only for concepts. Binomial theorem, put a separate 100 pages long, white long notebook. All the formulas, concepts write in that book. Binomial theorem, permutations and combinations. Together you write down one in one book. Always read the definitions. Okay now? So if you go on read the definitions, recapitulate, revise the concepts, whenever you come across this type of problem, immediately this result will strike. So if you don't know this result, solving this problem is somewhat difficult. Understand this? Very difficult to solve. So if you know this result, the answer is within minutes you can get the answer. That's why write all the concepts in a separate notebook. So by every day when preparing for JEE mains examination, so just 1/2 an hour, start beginning of your preparation, every half an hour, you read all the formulas, concepts, then only you start the problem. Generally students, what they mistake is, whenever they sit for preparing the examinations for JEE mains or whatever may be that, they immediately start solving the bits. They will take one chapter and they start preparing the bits. That is a completely wrong procedure. So whenever if you start the chapter binomial theorem, so immediately take the synopsis, write all the formulas, read the formulas, recapitulate, remember, then you start the problems. Okay. So I hope that you understand this concept. So let us start one more concept. So dear students, welcome to a very interesting concept, that is divisibility. Divisibility of concept. What is that divisibility means? What is meant by a divisibility means? Let us see here. We know that 6 divides 24. 6 divides 24. Then how can you say that 6 divides 24? Just in general concepts, we will divide with 6. 6 fours are 24. Remainder is 0. Very clear. So here 24, that is a dividend, is equal to divisor into quotient plus remainder. That is equal to 6 into 4 plus 0. That is equal to 24 is equal to 6 into something. So that means if you are able to express 24 is equal to 6 into some integer, then we can say that 24 is divisible by 6 or 6 divides 24. It is a very simple example. Now coming to generalize this, we will generalize. So here A divides B. A divides B or B is divisible by A means what? A divides B. 6 divides 24 means what? 24 is equal to 6 into something. Like that, B is equal to A into some integer. Some integer. If you are able to express, now these two are vice versa. That means, if A divides B, then you can write down B is equal to A into some integer. That is, B is equal to AK. A into some integer. If you are able to express B is equal to A into K, then we say that A divides B and B is divisible by A. Understand? Okay. So, this is the divisible, very simple concept, divisibility concept. Okay. Right. So, basing on this, we have very important problems. Okay. So, let us see that problems. So, welcome back that. So, basing on the concept, so we are going to do this problem. So, that is prove that for each n belongs to natural numbers, 2 to the power of 3n minus 1 is divisible by 7. That means, so if you substitute n is equal to 1, that is a 2 cube 8, 8 minus 1 7, 7 is divisible by 7, right. If you substitute n is equal to 2, 3 2s are 6, 2 to the power of 6, 64, 64 minus 1, 63, 63 is divisible by 7, that is 7 9s are 63. That how to prove this theorem in a general method. Okay, now what we have to prove? We have to prove that 2 power 3n minus 1 is divisible by 7. That means you have to express 2 to the power of 3n minus 1 is equal to 7 into some integer. If you are able to get this result, the problem is over. That means 2 to the power of 3n minus 1 is a multiple of 7. If you are able to show that it is a multiple of 7, the problem is over. Now, coming to this, first take this expression, that is equal to 2 to the power of 3n minus 1. 2 to the power of 3n, I will write it as a 2 cube whole power n minus 1. 2 cube means 8, 8 to the power of n minus 1. 8 here only our skill, mathematical skill will come out. Here we have to prove that it is divisible by 7. It is divisible by 7. That's why here 8 is there. No, you express this as a something plus 7 or something minus 7. Okay. So, this is can be written as a 1 plus 7 whole power n minus 1. Can I write it as a 1 plus 7 whole to the power of n? 8 can be expressed as 1 plus 7. Of course, you may ask here, sir, 2 plus 5 also we can express. But the thing is, we want 7. That's why express 1 plus 7. Now, 1 plus x whole power n expansion. So, we know that, so that is equal to nc0 plus nc1, of course 7 here, n means for 7c0 plus 1 into 7c1 into 7, 7c2 into 7 square plus so on last one 7c7 into 7 to the power of 7, of course minus 1 is there. Understand here, 7c0 value is 1, last also minus 1 is there. That's why this 7c plus 1 minus 1 get cancelled. See here from second term onwards, here what is there? 7 is there. Here 7 square is there. 7 cube is there. Last and final. So here nc, so here n only, sorry here n only. So n, nc1, nc0, nc2. Why? Because here whole power n is there, no? That's why nc1, nc0, nc1, nc2, so on, ncn. 7 to the power of 7. Understand? nc7. Last one is nc7, it's so on. So on, so here we will get nc0. So here 1 to the power of, so 1 here, so 2 here, 3 square, not 7. So on it will come. Next to it will come ncn whole to the power of 7 to the power of n, you will be get. 7 to the power of n you will get. nc0, nc1, nc2, so on, ncn 7 to the power of n. Last term, that is a last term, right. Now this NC0 minus 1 we can get cancelled. So here see here 7, here 7 square, 7 cube, 7 to the power of n. So we can take a 7 common outside. We can take simply all are multiples of 7. So you can take 7 common outside. So this is a NC1 and this is a NC2 into 7. This is a NC3 into 7 square. Last one NCn into 7 to the power of n minus 1. So if you observe 7 into what is this? Is it not a positive integer? So it is clearly a sum integer. Sum integer. That means what? You are able to express 2 to the power of 3n minus 1 as a multiple of 7. See, therefore, we can say that 2 to the power of 3n minus 1 is divisible by 7. Understand? The whole problem lies here only. 8 to the power of n minus 1. In place of 8 you write down 1 plus 7. That's all the problem will come. Okay. So I hope that you enjoyed this problem. Let us see the next problem. Welcome to this concept. This concept is remainder problems. Remainder problems. So this is a very important application of the binomial theorem. Very important application of the binomial theorem is remainder problems. What a remainder problem means? For example, if you divide 24 with 5, you know what is the remainder. What is the remainder? So 5 4s are 20. The remainder is 4. Remainder is 4. 4 is a positive integer. Since it is a very small number, that means here 24 can be written as, so dividend is equal to divisor into quotient plus remainder. Understand? That means if you want to find the remainder of 24, you have to express 5 into some integer plus whatever may be the number which is less than 5. Which is less than 5 will become the remainder for that. That means if you now generalize, if you divide x with y, so let us the remainder is r, then some quotient is some z, then x is equal to y into z plus r. X is equal to y into z plus r. This r is less than, strictly less than y. That r is strictly less than y. Y is less than r. Sorry, r is less than y. R is strictly less than y. Understand? Strictly less than y. Then whatever may be the remainder. That means whenever if you want to find out a remainder, that means you have to express x in terms of y into some integer plus so whatever may be the output will come, that will become the remainder. Okay now. If it is a small problem, we can do easily. If it is a very big numbers, very big numbers, for example, 5 to the power of 5 to the power of 5. If you want to find out with the 6, if you want to find out the remainder, that means 5 to the power of 5 to the power of 5, it is divided with the 6, then what will be the remainder? Now, let us see that. See, this type of problems are very important problems, so don't go away. So, watch this class. Okay now? Welcome to this problem. Find the remainder when 5 to the power of 99 is divided by 8. So 5 to the power of 99 means you have to multiply 5 with 99 times. Then you have a very big number will come. You have to divide that number with 8. Then you have to find out the remainder. Okay, that means what? You have to express this 5 to the power of 99 as a 8 into some integer. 8 into some integer plus something k. This k value should be strictly less than 8. Whatever may be the k, that is your remainder. How to find out that k value? Okay now, so let us see this. First 5 to the power of 99. Can I write down 5 into 5 to the power of 98? Yes, I can write it, no problem. So this is equal to 5 into, can I write down 5 square into whole to the power of 49? Yes, I can write it. No problem. That is a 5 is equal, this is equal to 25. That is a 1 plus 24 whole to the power of 49. Can I write down? Why? Because here for 24 is a multiple of 8. 24, 8 3s are 24. That's why I wrote 1. That means here you have to be able to express something 1 plus 8 or 1 plus 16 or 1 plus 24 or 1 plus 40 like that. Understand? So you have to express as a multiple of 8. That is the main that is the skill that applies here. That means here 1 plus something, that something should be multiple of 8. Now the problem is over. So this is equal to 5 into. Now express 1 plus 24 whole to the power of 49. So this is equal to 49C0 into 1 plus 49C1 into 24, 49C2 into 24 whole square plus, so here plus, so this is a 49C3 into 24 whole cube plus so on last 9, 49C49 to the power of 24 to the power of 49. Understand this? Understand this? Okay, now 49C01, how much? 49C0 is equal to 5. So this is equal to 5 plus this 5 into this whole thing, 49C1 into 24 plus 49C2 into 24 whole square plus so on last one, 49C49 into 24 to the power of 49. Okay, now? Right. See here 24 is there. Here 24 whole square is there, 24 whole cube, 24 whole to the power of 49. So can I take 8 common outside? 8 common outside, yes, I can take common outside. That is equal to 5 plus 8 into 5 you multiply inside, no problem. So that is equal to 49C1 into 5 into 24, already 8 came, 3 will come. So 3 plus 49C2 into, so this is equal to 5 into already 124 or 8 came. So that is got 8 3 and one more 24 kilo. So whatever may be that here also some here. So 3 into 24 whole to the power of 48 will come. Okay. 8 3 are 24 into 5 also will come. No problem. No problem. So on the whole what it is there? It is there 8 into something we got. So 8 into some integer. 8 into some integer plus 5 we got. 8 into some integer plus 5. Is it 5 less than 8? Yes, strictly less than 8. Therefore, this 5 is the remainder. Understand? So, here onwards, is divisible by 8 means you have to express 1 plus multiple of 8. Divisible by 9 means 1 plus multiple of 9, 1 plus 9, 1 plus 18, 1 plus 24, 8 3 are 27 like that. If it is a divisible by 24 means 1 plus 24. If it is divisible some 100 means 1 plus 100. So that is the main, if you are observe the technique, the problems are very, very easy to solve. Okay, now. So I hope that you enjoyed today's class with some more problems. Tomorrow I will stand before you, and I hope that you are all preparing seriously for your JEE mains examinations. So in every day, so I will stand before you. I will explain all the basic level concepts. So watch my videos daily and comment and like the videos. If you want any chapters to be discussed, you just comment in the comment box. Definitely I will take up that chapters. Okay. So until then, all the best.